Hello, this is Lara Rubbelke. Today on Azure Friday, we're going to be learning all about Azure Data Lake Storage Gen 2. And with me today, I have James Baker, who is the Program Manager in charge of Azure Data Lake Storage Gen 2. James, can you talk to us a little bit about what you want to share with us?
Yeah, thanks, Lara. I'm super excited about the new storage service, Azure Data Lake Storage Gen 2. What we're offering with this is a new capability dedicated to analytics built on top of Azure Blob storage.
Okay.
And so what that comes up is that it becomes a multi-modal cloud storage service, the first in the cloud, and we're super excited about this because it really delivers the best of both capabilities, driving the storage service and becomes the future of what cloud storage becomes.
Well, what does multi-modal mean?
Yeah, okay, so previously in the cloud, what we commonly had was things called object stores.
Right.
So Azure Blob Storage is an example of object store, S3 is an example of object store, GCS is an example of object store. What they are is have a very flat hierarchy, just simply store the objects, very low overhead, makes them very scalable and very cost efficient.
Right.
So we can see that here, just a simple example. What we've got is the convention of putting slashes in the name, but as far as the storage is concerned, it's just part of the name and doesn't consider the structure. The other sort of paradigm that is very existent, if you've ever used your local computer, you're used to a hierarchical file system where the file system organizes this data into a structure of directories and subdirectories, leveraging, just simply organizing the data in a sort of an efficient manner. And more importantly, analytics frameworks have taken advantage of this arrangement and they've built special features around it. And so what we're going to see today is an example of how that how the analytics engines take advantage of those features. But in the cloud, we've either had to do an object store or a file system, and we've never really been able to bring these things together. And so customers have had to make a choice of trading one set of qualities off for another set of qualities.
Or store their data twice.
Or store their data twice, creating islands of data, which
Right.
is exactly what goes on. And so what we're doing with Azure Data Lake Storage Gen 2 is combining those qualities, providing it in a single unified capability to endpoints. So we've got an object storage endpoint, we've got a file system endpoint, all converging around the same data. And so that's what makes this so dramatic and so important for analytics workloads. And so no longer do you have to sort of compromise in your choice around cloud-based storage, whether you want the qualities of object store or file systems.
And so you can use that same data that's stored once and use it no matter what kind of application need you have, whether it's analytics or your typical, I just need to be able to store that data and access it.
Exactly right,
Great.
yeah. And so what I want to show now is a quick demo which shows how important having file system capability at object store scale is to analytics workloads.
Okay.
So if we go into the demo here I am in the bash shell for my HD Insight cluster. I could call out that I can do this on Azure Databricks as well, just happen to have picked HD Insight. And one of the things we can do is we've always been able to look at examples of how we've been able to talk to, there's the command, how we've been able to talk to remote storage. This is not a new capability. We've always had the WASB driver or the ADL driver. But the nice thing to point out here is a new capability that we've introduced, the ABFS driver, the Azure Blob file system driver. And so this is now built across the top of Azure Data Lake Storage Gen 2, which gives us access to this great capability. And so here we've got an example of a directory. Let's have a quick look at him. If I count the objects in here, there you go, there's almost 5,000 objects in there. Now, this may sound a little bit trite, but what is very common in analytics workloads is that the job processes in parallel and typically writes the output into a temporary location. And then as the job completes, it renames that temporary location to the real output name location. And in file system-based activities, this is a metadata operation. But in object stores, which are approximating a file system, what this means, because object stores don't have the notion of directories and don't even actually have the notion of renames, what this means is that the file system driver has to go through, get a listing of all 5,000 files, and then do 5,000 copies and 5,000 deletes of the original, and that's how it approximates a rename of a directory. And while it does this quite successfully, it takes time. And so if I was to, for instance, execute this command, that command, on WASB with 5,000 files, this would take in the order of minutes. And so as we run this now, because it's a first-class file system, what do we got? 2 seconds. And that, a lot of that is the JVM starting up. So that's an example of how we get significant performance improvements which directly benefit analytics workloads.
Okay.
The other piece we want to talk about with Azure Data Lake Storage Gen 2 is how this is now the convergence of our 2 existing remote storage services. We've always had the Blob storage service, which has great qualities for cost effectiveness, regional availability, redundancy options. You can either have local, zonally, geographically redundant options, which gives great a BCDR stack around your data. We've also got lifecycle management where you can tier the data out. We know that when data's new, it's very, very valuable. But as it gets older, more than 30 days, customers have often got a choice of saying, oh, well, the value that I get out of it versus the cost of storing it becomes negative, and so they delete the data. But they don't really want to delete the data. They just want to store the data cheaper. And so we've got tiering capabilities with the hot, cool, and archive tiers in Azure Storage, where you can store that at up to 1/10 the price that you would have of some of the hotter tiers. And so we've got life cycling around that, which is super important for analytics data when you're building these enterprise data lakes. Other things, we've got a larger partner ecosystem around Blob storage, and we want to be able to take advantage of that. We don't want to recreate the ecosystem around a new service. We want to be able to leverage the existing ecosystem that we've got. And then we've got the Data Lake Store service. And this has always been built for analytics. It's primarily optimized for Hadoop in terms of the frameworks that work on Hadoop, such as Spark, such as Hive. This is what the Data Lake Store was optimized for. It had file level security, which is super important to folks building enterprise-wide data lakes. You need to be able to secure these things. You can't just have full access. I don't want to give you the keys to my entire data lake and give you access, especially if you're in the accounting department.
Right.
And so in the marketing department, we want to keep our data separate from you accountants. And that's super important, that we can't build one without a good structured ACLing system. And so that's what the existing ADLS service brings us. The other things is that it had very large scale. It's no secret that in the Blob storage service, we used to have very sort of rigorous scales at the account level, scale limits, and that caused problems for a lot of big data analytics. ADLS went and solved that, and we're bringing that quality through to the new ADLS Gen 2 service. And so really what we're saying is we're bringing the qualities that people love out of both of these separate services and converging them into the same service. And that's super important because, again, it gets you out of the tyranny of all. You're getting the best of both worlds and bringing it and only storing the data once and not having to move it. And all of this. Moving data around, super problematic, super expensive, multiple copies of data, terrible. So bringing it all into the one single place and doing analytics and ingest and all of the work that you want to do on machine learning is super important. So I just want to jump in now and do another demo.
Great.
This is a fairly basic demo because it uses Hive. Hive's maybe not the coolest thing in the shop anymore, but it does reinforce a lot of the capabilities that all of these analytics engines take. And so one of the first things you do here, we've got a simple little bit of table definition, which goes and puts structure around an existing set of data. So we're not copying the data with this. We want to be able to create metadata around this.
So what you have here, you have a Hive statement. It's creating a table, and it's applying a structure over existing data.
Yes.
So this is your traditional Hive.
Yes.
But you're doing this against what this new converged storage system.
Exactly right.
So,
And so if I jump over into Storage Explorer, we can see the data here.
Right.
And what is very common, especially around things like logs data, is that it's already structured. We
Right.
get logs piling in by the year, by the month,
Right.
by the day, by the hour. And so, this is sort of very typical of the way that data is already structured. And so the sort of architects of Hive have sort of recognized this sort of quality, not just because it's a sort of naturally occurring phenomena around the way we organize data today, but it also provides huge performance opportunities for the Hive query engine. And so when you see here, we've got all that metadata. One of the key pieces of metadata we put out there is the notion of petitioning. And so this petitioning structure mirrors the natural structure that we've got now embedded within first-class directories. They're not sort of approximations, they are directories that we're seeing. And so the petitioning mechanism we're putting out here mirrors that. And then the other thing we say is we give it a specified location. And so that location there, again, is just using the ABFS driver that we saw in the first demo.
Yep.
And it's just specifying a location. So again, it's not saying, I need to move the data into my database. I'm just pointing the metadata out at that existing location and away we go.
and then it infers that structure, the hierarchy structure that you have in your partition by that is in that hierarchy or in that directory as well.
Yes, exactly right. And so actually, and that's a great point because it comes in sort of two parts. So the first one, we're running the DDL now because that's just metadata. That comes back very, very quickly. And so now if I go and run this command, we can see that, let's try and minimize that away a little bit. We can see there's our blobs logs table there. And if I scroll down through the description of it, you can see all of these fields that we specified, and that's great. Now we've got the petitioning information there, and the key point we've got is the location, which again preserves that ABFS location. The data isn't moved. And so the second part of what we want to do is go and discover those petitions. Hive's got this slightly quirky command, the MSSCK repair table command, which goes and crawls over the store from that location we specified and discovers all of those petitions automatically. And so if I kick this off, again, this is able to take advantage of the directory structure, which is part of the hierarchical file system, which is part of ADLS Gen 2, is able to go and efficiently crawl this data, discover the petitions, and build them into the metadata that's keeping around this table. And so when this comes back, which hopefully won't be too much longer, this will be great. Go and count us out, Lara. Here it is, it's finished. Oh, now give us the results. Oh, it's hidden the results. Oh, there we go. Right, perfect. We can see now we've got thousands of petitions which reflect the thousands of directories that we had in that location. But what that means now is that I can go and issue a command, a select statement in Hive that uses predicate which aligns to the petition structures that we've got. And what that allows Hive to do is say, oh, I can prune out all of these petitions, 99.9% of the data I don't even need to process, don't even need to look at. And so it prunes out these petitions, runs the query, and this query isn't cached, it's not using any fancy tricks of the engine, it's simply now saying, oh, I only need to go and process this very small piece of data, and so now it can serve the results back to me very, very quickly, even after applying all of the metadata pieces that we want as the serializer. So that's sort of a very simple example of how Hive makes the directories, makes the hierarchical file system beneficial to analytics workloads in a very real way. So the last thing I want to sort of talk about is what this means to the Azure platform, because we've got a lot of first-party analytics services. We've got HD Insight that we saw here. We've got Azure Databricks. We've got SQL DW. We've got many analytics services which offer great value to customers. They can run and extract value out of their data. And Azure Data Lake Storage Gen 2 has been integrated into these services, and we're really sort of pleased about how that's going. The other key point we want to say is that this is now available to third parties as well. And we're working with a lot of great third-party partners to make sure that they're integrating here, so that it's not a choice. We're not forcing you down one analytics engine solution. If you've got a commitment to a specific ETL provider or a specific data governance provider, we want you to come onto the platform, preserving those relationships, because I know they're important to customers. And so, the third parties that we've been speaking to, the ISV ecosystem, are really resonating with this well, because previously they had to integrate twice with WASB and ADL. Now they only have to do a single integration, so the partners are super pleased about it. They're also super pleased about the qualities that it's bringing, and so they're very eager to come and build on top of this. The second point I want to make here is that, and you've already touched on it, there's no longer islands of data. There is just one data lake. And as long as we give it structure and we make it manageable so it doesn't turn into a data swamp, you no longer need sort of optimized stores or optimized copies of the data simply because my analytics engines works there. We want to make sure that ADLS Gen 2 performs its best for all analytics capabilities, regardless of what their data access pattern is. And so we're making changes, and we're not just treating this as a stream of bits. We're optimizing it based on the access patterns of all these analytics engines.
And that then also makes it available, much more easily available across all regions.
Of course, yes.
Right.
And that's a key point, because it's built on Azure Blob storage.
Which is everywhere.
Yes. At the end of the day, ADLS Gen 2 is a set of capabilities built on top of Blob storage. It's not even offered as a separate service. You go and create a single storage account. You just simply enable the namespace. And so, yes, Blob storage is in all 50 regions. ADLS Gen 2 is also going to show up in 50 regions.
Great.
Cool.
Great.
And so, last piece, yeah. So we're in public preview now. We're super excited about that. The response has been great. And so here's a sign-up link that gets us access to the public preview. We just want to know a little bit about the sort of the workload information that customers are going to be using it. So we make sure we're understanding the workloads that are applying. It's not about filtering people out or anything like that. We've got a great product information page, and so there's now a unified story about how to build enterprise data lakes on Azure. So please come and consult that. We've also got documentation, and we're going to build out this documentation throughout the public preview so that it really sort of tells a great story, and customers can really and easily understand how its benefits apply to them.
Fantastic. Thank you so much, James. I am also really excited about what we've got with the Azure Data Lake Storage Gen 2. I'm looking forward to working with customers on their solutions with this service. So great work,
Cool.
Really great work.
Thanks, Lara.
All right. And we've been learning all about Azure Data Lake Storage Gen 2 here on Azure Friday.